So I have good news. I got permission to not use the MyMathLab test, instead to do my own test. So that's good because then you don't have to worry about formatting. The reason I sought that permission was, one, it's a small class, and two, which I am putting, I'm like, okay, that means you gotta grade the exams while you're doing your own grad school stuff, but that's okay. But I'm already going in and grading for partial credit when you take it on MyMathLab, so I might as well go in and grade just the problem itself. Because I feel like trying to give partial credit maybe takes longer than if I was to just look at your original work. Yes, no, partial, move on. So your exam is going to be on paper from me, which means your review will be on paper from me. I will put your grade in Blackboard so it'll override the test assignment in there, okay? I will be missing, I don't know how many days, I will be missing for a funeral soon. I have to go to South Alabama, but I'll keep y'all updated on that, and I'll try to make it to where you have to take the test with me. I have to proctor it, or maybe I can pull someone in the building that is also GNTC for you to proctor it. I don't know. I'll let you know. But I would be here for the review. I wouldn't do that to you, so. All right, 6-3. Let's finish this before the board decides to give up on me again. Oh, it didn't save my writing from yesterday, did it? Nope. Okay. We were talking about reference angles. We said reference angles are the angles that close the gap when an angle opens up, rotates. A reference angle is the gap from that terminal side to the x-axis. Did we do these? We did these two, right?
We're on the next slide.
Did we do these?
The first 2 minutes.
And we just drew the picture, right? Has everyone tried to draw a picture of E13? Because you're finding all 6 trig functions, but practice the drawing. But you can practice the 6 trig functions. I can give you the answers to them. When it comes to the 6 trig functions, that's just you practicing rationalizing. You just put them in the fraction. It's drawing the picture where you could go wrong. Has everyone, so y'all saw the picture here, right? All right, what about 495? So let's walk through this from yesterday. I don't know where 495 is. It's too much, so what would I do to calibrate it? Take off a full rotation. The vocab behind that is we're taking off a full rotation and we're getting what's called the coterminal angle. So as I find the 6 trig functions of 495, I will get the same answer as if I found the 6 trig functions of 135. 135 is easier for me to visualize. So I'm going to go with 135. You're going to draw a picture based on where 135 lands. So you got to imagine initial side. This is 90. This is 180. So I've gone too far. So it's in quadrant 2. So it's going to open up and land in quadrant 2. I like to draw a line and just say, okay, there it is. Then I like to go to the next x-axis and mark what that measures. So this measures 180. And then the reference angle, y'all stay with me, is the gap in between right here. This is the reference angle. So 180 minus 135 is what? And then you finish that right triangle, which I didn't draw this very well, but there we go. You finish the right triangle. Then you're going to have the sides of the special right triangles memorized. When it's a 45, 45, 90, it's 1, 1, root 2. And these are opposite, like 1 is opposite 45, 1 is opposite 45, root 2 is opposite 90. So hypotenuse is root 2, this is 1, this is 1. Here's where some people go wrong. What have I not done? There's a negative in here because I'm in quadrant 2. So make sure you put a negative where there's supposed to be one. Now your picture is completely set up, and now you would do sine, cosine, tan, and the 6. So you do all 6. Sine, cosine, tan is in this chart. Just watch your negative. So some people don't like the chart because it doesn't have a single negative. Some people just like to draw the picture, look at the picture and write it. It's up to you on how you want to do that part. Do you have any questions on that? It's the same thing throughout the whole, pretty much the whole thing. 6.1 to 6.3 is finding the 6 trig functions. The complexity changes. It's either really simple, it's the special right triangles, or it's any angle and you have to calibrate it down. You have to calibrate it down to something you can work with. And then this new part is, instead of actually finding, so here's the purpose behind reference angle. Because you might be thinking, why didn't I just find sine, cosine, tan of 135? Because you could. You go to your calculator, you type it in, you're good at the decimal. The point of it is finding the sine, cosine, tan in radical form, so no decimal, from basically memory. Notice I've not used a calculator at all. Like, I don't need a calculator. Like, that's the purpose of the reference angle. You can take a really ugly trig function, you can calibrate it, draw it, get the reference angle, and then answer the 6 trig values with no calculator at all. So that's the reason why. Go to this one right here. This is finding the trig values, rounding to 4 decimal places where it's appropriate. Look up here at the top where I've given you some info. It should be easy to find the exact trig values of the special right triangles, 30, 60, 90, or 45. Those are from the chart. Draw the picture. But if it's not, you could always use your calculator and round your answer. Looking at these values, first of all, that has a decimal. 175, that's only 5 degrees reference angle. So I can't do the special right triangles because 5 is not one of them, right? It's only 30, 60, 90, or 45. So these are examples of finding trig values of angles that do not have a reference angle of 30, 60, 90, or 45, which means you have to use your calculator now. You can't do these in your head. So make sure your calculator is in degree mode. Make a note. Mode has to be degree. And now you're going to just type them in and round to 4 decimal places. Remember we talked about when you get to the reciprocal ones, the reciprocal functions, you cannot type those in the calculator. You have to rewrite it as the reciprocal fraction. Here, try this. those his AirPods?
Those are loose.
Okay. So like the reciprocal of secant is cosine. So I would go to my calculator and enter 1 by cosine 500. There's no need to take the 500 and subtract off a rotation because we are relying on the calculator here anyways. It would be the same answer if you did 500 or if you did what is it, 140.
Oh my God.
Colby. Oh, shoot.
All right, let's see if you got the right answers, or let's see if I have the right answers. I got, this is just a matter of typing it in, right? Make sure you understand how to do this. That was just typing it in. This is, you have to tweak it in terms of sine, cosine, or tan. So you have to rewrite it as the reciprocal and then type it in. Did you get this? This, although it's negative, it's tan, which means you can just type it in. Cosecant, can I type that in?
No.
No. How do I rewrite it? Look at that first letter and just remember they're opposite. So it's 1 over sine 351.75. And you get that. Even here, cosine of 2,400, don't let the angle make you think the math is any different. It's the same math. You're just typing it in. Sine of 175. Cotan, how do I rewrite cotan? 1 over tan. And this is negative 135. You would type it in your calculator, but let's do it in our head. Negative 135. How close is that to negative 180? $45 away?
It's like your staples.
That's what I was wondering.
It's like slowly walk past me.
Did that Landon kid? Did you make it? Oh, I'm good. I've got something. Thank you, though. I appreciate it. No, that was sizable. So what's tan of 45? Well, 45 is that isosceles triangle. Tan would mean the legs that are both 1 and 1, so it's 1. Okay, go to this page. Now, there's only 2 from the textbook, but I was like, no, I think you might need 2 more. So there's 4 practice problems here of the exact same thing. It is exactly what you just did. The difference is we're not finding the trig value, now we're finding the angle. Okay? So notice the ugly decimals. They're giving you the trig value. We're trying to find the measure of theta. which means we're using what in our calculator? Inverse trig. There's a little bit of, there's a couple of layers here. The first layer is we need to know what quadrant we're in. And the second layer is we need to know the reference angle. Possibly, depending on where it lands. Alright, so let's take some notes. Given the function value and the quadrant restriction, find theta, which means find the angle measured. Don't distract you. We've got sine theta equals 0.2812, and then you have a comma, and then it says 90 degrees less than theta less than 180. Let me explain how to read this. This is the same thing as like that. Same thing. The difference is the angle is unknown. Okay? The angle's the goal. Alright? Let me go back over here. Take that off. This is a fancy way of telling you the quadrant you're in without using the word quadrant. So the way you read it, always read it from the middle. I guess I'm going to draw an arrow. I don't really have room, but always read it from the middle. They're telling you the angle you're trying to find is between 90 and 180. Then imagine those quadrant, or those marks, like quadrantal angles. 90 and 180, which means it's quadrant 2. So this is saying quadrant 2, Q2. Right? Okay, let me pull my calculator up so you can see how I type this in. Alright, it's already in degree mode. We have sine theta equals 0.2812. We know we're in quadrant 2, so I'm going to come over here and draw a picture. My picture is going to represent an angle, always starts in quadrant 1 on the initial side, and it's opening up and it's landing in quadrant 2, right? Now we're going to figure out what theta is from that sine value. So I'm going to put a question mark right here. This is very similar to the writing that I've been doing every time we drew our pictures. I would draw that it's opening up, and then I would draw the line to say, okay, here it is, it's 135, right? Well, this time I don't know what it is, but I do know it's landing in quadrant 2. So I'm going to draw that it's opening up. I'm going to come out here to the end, and we'll put a question mark to let me know, okay, that's what I've got to find. Now, here's what I've got to work with. Sine theta equals this nonsense. Let's go ahead and do inverse sine and figure out what this nonsense is as an angle measure. So inverse sine, so sine inverse of 0.2812 equals what? Got 16.3 degrees. We're going to go to the nearest. Oh, I don't know why I went to the nearest 4 decimal places, but we can go to the nearest 10th because it's an angle. Angles usually are to the nearest 10th. Sides are usually, or trig ratios, which are the nearest 4th. Now it's freezing here. 16.3. So theta is 16.3. here's where a lot of people get confused. Stay with me. Hello. Sometimes you come to the answer and you're done. Sometimes there's something that doesn't make sense. And you have to do one more step. What do you think the scenario is here? Yes. Okay. Remember what quadrant you're in, right? Stay with me. Brody, stay awake. You're in quadrant, you ate all that food and now you're sleeping. You're in quadrant 2. Does an angle that measures 16.3 degrees land in quadrant 2? No. So then, because you've made this connection, like, now wait a minute, that's too small to be a quadrant 2 angle, then that's actually the reference angle to that gap, like that gap to the nearest x-axis. So this 16.3 is actually, I'm going to change colors. I'm going to underline it in purple, and I'm going to come right here and put theta. Now this is not always the case. Sometimes the answer fits, but in this case it doesn't fit. We should be in quadrant 2, not quadrant 1. So this is 16.3 degrees. This is 180. So how do I get the measure of my angle?
We subtract 16.3 from 180.
Yep. And I get 160. What'd you say?
164. Oh, sorry.
Now, here's what's cool about this. While this feels really complicated, it's kind of like, whoa, now wait a minute, that was a little... While none of it was challenging, it was just like, how do I know when I have to keep going? We knew because it didn't match the quadrant we were supposed to be in, which is why the picture is helpful. It'll help remind you where you should land. But what's nice about this is everybody go to your calculator and type sine 163.7. What do you get? You get 0.2812.
No.
Well, remember we did cut off value. We cut value off.
It's a 2. I got the 0.28.
Yeah. So it's a little off because of where we rounded. It's not going to be perfect. But it should be close enough that you can look at it and be like, okay, then I did that right. So there's a layer of checking your work here. Okay? Let's do another one. The textbook thinks you've got this in 2 examples. I think you needed 2 more. Because like I said, sometimes when you do this, you get the answer. And then sometimes you have to take another step. So try the next one. Cotan. Actually, let's hold off on reciprocal, just because some people get confused. Go jump down here to cosine. Let's do the cosine one. It's the same thing, yeah. So cosine theta equals negative 0.98 or 9388, and then it says in the interval 180, 270. This is another way to see it. What quadrant does this mean? This is quadrant 3. So it helps if you sketch a picture. So we've got some angle opening up to quadrant 3. We don't know it. So we're going to go to our calculator. Go to your calculator and let's go ahead and do that. Theta is the inverse of cosine get this angle. 159.9 degrees.
What'd you say?
159.9 degrees. Okay. Is that our answer?
No.
No, we have a problem. We should be in quadrant 3. 159 lands us in quadrant what? 159 is going to land you
Quadrant 2.
quadrant 2, right? So I'm going to make a note that this is 159.9 right here. This is why the picture is helpful. We have actually 2 steps to do to get to this angle here, and they both come from the reference angle. So 159.9 has, I'm trying to change colors. This is to 180. So what's the reference angle from 159.9 to the 180? How do I get that?
Subtract.
You're going to subtract. So 180 minus the 159.9. Tell me what you get.
20.1.
20.1 degrees. What do you think I need to do next? The goal's here. They're going to have the same reference angle.
Mm-hmm.
Subtracted from the 270.
Never use the y-axis.
Oh.
But I'm glad you're thinking. Never use the y-axis. It's always 0, 180, or 360. So this, it has the same reference angle. So then what goes here? 20.1. So how do I get this? You add it to what? To 180. You see that now? So think of it as steps, like increments. So now I'm going to take 180 and add to the 20.1. And you get 200.1 degrees. So this is 200.1 degrees right here. And then now you can go to your calculator and say, what's the cosine of 200.1? And you should get approximately negative 0.9. Yes, we are. Bless his heart, he just left. All right, now let's do the reciprocal ones. We did two regular trig functions. Now let's look at 2 reciprocal ones. Cotan. We have cotan theta equals this negative decimal. I can't work with cotan. I need it sine, cosine, or tangent. So there's 2 ways to arrange this. One way is that cotan theta equals this. You could change that to 1 over tan theta equals this, right? In cotan 1 over tan. Okay. Not gonna have a lot of room here. Let me do this. Cotan theta equals negative 0.611. Okay. All right. So one way to do this is to say, okay, I don't want to deal with the reciprocal. I'm going to change that to 1 over tan theta. You see what I changed? I just changed the cotan to 1 over tan, right? Okay. But tan is now in the bottom of a fraction. I need it up in the normal. So this is a proportion. This is understood to be over 1. So you can cross multiply this, which basically is going to do a switcheroo. This is going to multiply up here, and then this one would multiply, you can multiply it down, which sounds really weird to do, but if you need to see the long version of it, here's what it would look like. I would never expect you to show this long version. but you might need to see it one time to understand why it moves. Then you can come in here and divide that over here. Alright, so that's the long version, okay? I would not want you to do that every time. That's too much. The short version is to say cotan theta. This is what I started with, right? I don't want cotan. I want tan. I don't want to change cotan to 1 over tan because then tan's in the bottom. So I want this to become tan. You have to have a reciprocal in there somewhere. Put it with the fraction. Put it over here with the number. So this would be 1 over. So you can jump straight to that, okay? So let me explain it again, because we only had this happen, I think, one time in the homework, and now it's happening again. This is the long process behind it. Y'all stay with me. This be marking out. All right, so this is the long process. This is what I was given. I changed it to 1 over tan. I cross-multiplied tan to the right. I divided the decimal to the left. So tan is 1 over the decimal I started with. That is going to happen every time in all reciprocal functions. So when you are given this and you want to change it to tan, but you don't want tan in a fraction, then write tan like normal and make the fraction with the decimal. Move that to the denominator. It's the same concept, okay? So instead of 1 over tan, we write 1 over the decimal. Y'all with me? All right, so now I'm going to go back to my paper so you can actually see this like on paper. So we said this would be tan theta equals 1 over this mess. Now what quadrant am I in? I am in quadrant 4. So we'll try and draw. This is getting crowded. Note to self, I need to spread this out in the notes. I'm in quadrant 4. There it is. There's my question mark. All right. Now we have tan. Now it's the same thing we've been doing. So we're going to do tan inverse. So in your calculator, you're going to do tan inverse of this fraction. And tell me what you get. Is it 0.8 or 0.9? Okay, perfect. You get negative 80.8. Confirm you get that. It's negative 80 degrees in the parameters that they told me to answer. It is not. So now you go to your picture and you plot negative 80, and then you try to figure out how to get to the quadrant you're supposed to be in using either reference angles or coterminal angles. Okay? So where would negative 80 fall? Negative 80 would be quadrant 4. It would start over here and then it would land here, right? This is negative 80.8 degrees. I need the measure of the angle in quadrant 4 in the positive aspect. What would be an intuitive way to get that exact angle? Use the coterminal concept. What? Heard it. Add 360. We don't need a reference angle this time because it actually is the reference angle. We want it to do a full rotation and land right back there. So we're gonna do negative 80.8 and add 360. What'd you get, 279.2? And that's the angle. That makes sense right here based on my picture. Not bad, right? It's just like you just have to, it's meticulous, I guess you could say.
So then
That's the angle that they wanted it. So you could go to your calculator now and you could type 1 over tan 279.2 and you should get negative 0.16. I just don't remember. I can write it right here. I don't have it over. Yeah, this is the 279.2. Okay, try cosecant. You should find this one to be the easiest, and I'm curious if you can recognize why this one's easier.
it should have never eaten.
Too bad that's all you
You're in a food coma now.
I mean, like, my music stopped playing.
Oh, I hate that for you.
I understand what all we're
Are your
doing.
diamond shoes too tight too?
I don't have diamond shoes. My shoes are covered in black ink, actually.
You're supposed to be trying this one. What quadrant are we in?
The first one, quadrant 1.
We are in quadrant 1, so this is a nice simple drawing. We've got some angle opening up in quadrant 1, and you don't know it.
It's going to be 72 degrees.
But we do know the cosecant value, right? Now think back to the way we did the cotangent thing. Cosecant of some angle is this decimal. So I'm going to write, you can do 1 over sine, but then you got sine stuck in the bottom.
Yeah.
So I'm going to write sine equals 1 over here. And then I really don't need the 0 on the end. And then now I'm going to go to my calculator and do the inverse sine of that fraction.
And you get 72.6.
Don't act like you didn't know.
No, I really didn't.
You're lying.
How would I know?
I don't know. It just makes me feel good.
You did it?
Say,
No. Yeah, I'm actually doing my work.
Quick!
that sounds like one of those government
Things like this.
employees. I'm working. Hardly working.
Working hard or hardly working?
Right. I say that all the time. Does 72.6 make sense for the angle I was trying to find?
Yes.
Remember me saying at the beginning that some of these, when you do the inverse, you find the answer, and then some of them, you have to draw the picture, you have to map it out, and then you have to get to the answer. In this case, because I was in quadrant 1, and I came to 72.6 degrees, then it makes sense that that's my answer. I don't need a reference angle. I don't need a co-terminal angle. It landed right where my picture, it lined up with my picture, which is your indication you don't have any more work to do. It is the reference angle too, yeah. Quadrant 1 is always easier because of that very reason right there. Cotan was similar, but it was negative. In the directions wanted your answer to be as a positive angle in between the values 270 and 360. So we had to do the coterminal angle. So it was the correct angle. Negative 80.8 does open up and land in the same spot as the angle they wanted. But rotation matters, remember, and they want positive, which means it would rotate this way. So in that case, we had to do that at 360 to get the positive rotation that would land in the same spot as the negative 80. So yeah, very similar. So basically you have three types of problems. You got the bottom one, which is short sweep. Then you've got the tan one, cotan one, where you're on the right angle, but you have to do a coterminal. And then you have the other two where you have to use reference angles. Yeah. You should be working through your 6-3 homeworks. I'm going to go print the review for the mid-chapter 6 exam. Obviously, it would not be tomorrow because we always have a day of review first. There's a chance it's going to be Thursday, which would work out good. I think when you see the review, you might not be as panicked. Remember, this is made by me. This is not my math lab. So that's a good thing, right? Also remember, the entire section pretty much covers the same concept. It's just different layers of information. Thank you.